Okay, let's dive into the source material you've shared with us.
Yeah.
Today, we're focusing on percentages.
Right, percentages.
We all see them everywhere, discounts, stats, interest rates.
Absolutely, they're ubiquitous.
So the goal here isn't just definitions, but to really unpack the core ideas from this chapter.
See why they work, maybe where they can be a bit tricky.
Exactly. Think of this deep dive as like sharpening your tools for understanding those numbers you see day to day.
Sounds good. And honestly, the basic concept is pretty straightforward.
Yeah.
The word cent just means hundred, so percent, literally per hundred, out of 100.
That percent symbol is just shorthand for divide by 100.
Precisely. It gives us this common baseline, this way to talk about proportions no matter how big the original whole was.
And the source jumps right into expressing something as a percent. It uses that example. 7 out of 35 kids are absent.
Right. And saying 7 out of 35 is fine, but a percentage gives it context.
So how do we get there? How does the source explain it?
Well, the main idea is turning it into a fraction out of 100.
Okay.
So 7 out of 35 is the fraction 735. The source simplifies that first, down to 15. Then, to make it out of 100, you find the equivalent fraction. 15 is the same as 2100.
And boom, that's 20%.
That's 20%. Finding that equivalent fraction with 100 on the bottom.
Makes sense. But the source also mentions a faster way, kind of a key rule.
Yeah, the direct route. To turn any fraction or decimal into a percent, just multiply by 100 and add the percent sign.
So for 735, you just do 735 times 100%.
Yep, gives you 20%. Or like their examples, 410 becomes 40% because 400, 100 is 40.
And 0.3.
0.3 times 100 is 30, so 30%. It's all about scaling up to that per 100 base.
Okay, got it. Fraction or decimal to percent. Multiply by 100%. What about going backwards, percent back to a fraction or decimal?
You just reverse it. Divide by 100 and take away the percent sign.
Right, because the sign means divide by 100.
Exactly. So the source shows 12.5%. That becomes 12.5 divided by 100.
Which simplifies to 18 or 0.125.
Correct. And they have that slightly trickier one, 34%.
Oh yeah, a fraction is a percent.
Same rule applies. You divide the number, which is 34, by 100. So it's 34, 100.
Which is 3 over 400.
Or 0.0075 as a decimal. Tiny percentage. Same logic.
That 34% example really highlights how important it is to remember you're dividing the number itself, whatever it looks like, by 100.
Definitely.
Okay, conversions nailed down. Let's talk application. Expressing one quantity as a percent of another. The source mentions a critical first step here.
Yes, and it's one that, trips people up more often than you'd think.
Which is?
Make sure both quantities are in the same units. You can't easily compare, say, 40 paisa to 6 rupees as a percent directly.
Right, the source converts the 6 rupees to 600 paisa first.
Exactly. Now they're both paisa, so you can set up the fraction. 40 paisa compared to 600 paisa is 4,600.
And then just convert that fraction like before. Multiply by 100%.
You got it. 4,600, 100%. Comes out to 6 and 23%. The basic pattern is always part whole, 100%.
Okay. And finding a percentage of a quantity, like 20% of 60. That feels like the most common thing we do with percents.
It probably is, and it's straightforward. Convert the percent back to its fraction or decimal form, then multiply.
So 20% is 2,100, or 0.2.
Right, so 20% of 60 is just 2,100 times 60. Or 0.2 times 60.
Which is 12.
Which is 12. The source uses that class example, 50 kids.
Where 10% are in dramatics. So 10% of 50. That's 5 kids.
Yep, which means 45 are not in dramatics.
And the source also showed, thinking about the not part directly.
If 10% are in dramatics, then the rest must be 100% minus 10%.
Which is 90%.
So you can calculate 90% of 50 directly. 50 is always 100%. That's a really useful frame.
It is.
Okay, finally, the source covers percentage change, increases and decreases. This feels like another place where the starting point, the base, is super important.
Oh, absolutely critical. The source makes a point of this. Percentage change is always calculated based on the original value.
Not the new value. Never the new value. That's a classic mistake. It's the amount of change, increase or decrease, divided by that initial number, then multiplied by 100%.
So the formula is change original value 100%.
Exactly. Look at their examples. Increase 80 by 25%. The change is 25% of 80.
Which is 20.
So the new number is 80 plus 20 equals 100.
And decreasing 60 by 10%.
The change is 10% of 60, which is 6. So the new number is 66 equals 54.
And in both cases, that percentage, the 25% and the 10%, was applied to the starting number.
Always the starting number. That's the key takeaway for percentage change.
Okay. So we've covered quite a bit from the source. The basic per hundred idea, converting back and forth, comparing quantities, remembering those units.
Finding a percent of something and calculating percentage change, always using the original value.
What's really interesting is how these, well, fairly simple rules, all coming from per hundred, turn into such powerful tools for making sense of the world, for comparing things on vastly different scales.
It's true. It gives us that common language, whether you're looking at, I don't know, company growth or price changes.
Definitely. So here's something to think about. When you see percentage changes thrown around, news headlines, social media, ads, how might focusing on what that original value was change how you interpret those claims?
Yeah. Something to definitely mull over. Until our next deep dive.